Hey guys, how's it going? I hope you're doing all right. This is the next episode in the Coding Minecraft live stream. So what we're going to be working on today is possibly lines and getting some sort of physics working. So the reason I'm working on debug lines is because in order to get the physics working, I need to know what I'm doing, which would be very helpful. And how's it going, Langors and Tree? I hope you guys are doing all right. Basically what I've worked on sort of off stream this past week is gotten some pretty simple render stuff going. So like I have this render which has 2D stuff done pretty good because I just pulled all this stuff from the math animations library, but doing 3D stuff always makes things more difficult. And so the problem I'm currently having is when I'm trying to draw lines in 3D space, and I think I did not close that last time. So when I'm trying to draw lines, Oh, I just changed my shader, so I broke something. Here, let's change this real quick. I've been trying several different things to get this working right, but I have not gotten something right so far. So basically, when I'm trying to draw lines in 3D space, there's a problem where as I turn the camera, the lines look weird because this cube too is just like directly in front of the camera. But the lines look weird because they're in 3D space. So as I turn, the rotation gets applied to this quad that I'm just drawing in 3D space, and then it doesn't look right. So I'm probably going to work on this a little bit later because it's really annoying me right now. And this is good enough because I can visualize lines in 3D space. Like you can see, this is a line in 3D space, and I have a cube that's just sort of in front of me. So this should be good enough for debugging physics and stuff. So basically, I'll show you guys what I got with the physics so far too, which is not very much. So if I turn the physics back on, and I'm going to get rid of those lines too. And by the way, the lines too are pretty simple to draw. The API is basically just you supply this, just the start and the end, and then whatever style you want. So you can do like a stroke width, the color, and all that stuff. And then you just draw it. So, and then same for like drawing boxes and stuff. But I'll remove that for now. Actually, I'll just comment it out so that we still have that. So, nope, I can't comment today. Okay, there we go. No. There we go. Okay, that was too much trouble. Okay, anyways, with the physics, what I have so far is not working correctly at all. And that's the reason I had the debug lines drawn, because I'm going to have to fix that. So you'll see I fall, so that's good, right? Gravity works, but that's not good, what's happening here. And it depends on the camera's rotation. So like as I move the camera, things start getting weird. So I'm pretty sure I'm just like having some problems with my vectors and stuff, and basically like directional things. So I've got to fix that. But yeah, that's what we're going to be working on today. So I hope you guys are doing all right, and hopefully we make some good progress in this video. I would really like this to actually start coming together so that like you can walk and run and hopefully break blocks pretty soon too, because I think once we get those sort of core functionalities in, we should be good. Hey, I see Woods, and I am all better today. So it took me a little bit longer than I thought it would to feel a little bit better. And I may actually just start streaming on Saturdays again, just because I think that's more manageable for me. So we might go back to like that schedule, which, you know, I think it's probably a better idea. But I will continue working on this stuff in my off time because I think it's fun, and we need to start getting it ready because the 2D game engine series is almost done too. So yeah. Anyways, though, I think the first thing we can do with our physics is, first of all, we should draw the rigid bodies that we're trying to resolve static collisions for. And I guess this should probably be called dynamic collision because it is a dynamic collision. But anyways, yeah. So the first thing I'm going to do is I'm just going to say, let's draw a box. So we'll say render. How's it going, Xenix3? Good to see you. Which we're going to have to get from my render that I just built. And by the way, if anybody has any good solutions to those rendering problems with lines that you may have encountered, that would be good to know. So I'll keep looking on my off time and stuff though. Okay, so we'll draw a box at our transforms position. So that's sort of where this box should be for the rigid body. And then we'll draw the box collider's size. And for the style, I'll just do the default style, which I need to include that as well. And that's just like a white line. So nothing crazy there. I might change the stroke width on that though. So if I just go back into here real quickly. Yeah, I'm just going to change that to 0.1, which is a little bit more reasonable. Okay, cool. So doing this, we should be able to see any rigid bodies that are like being handled by the physics engine. So yeah, you can see there's sort of like a box around me, which is good. I do also have to add in rotation because it's not getting the proper rotation in. So we will have to add that, which if you go into Minecraft too, you'll notice that the boxes never rotate. So I'm still kind of debating whether I should have rotating boxes or not, or whether I should just keep it simple. And Tree, you can draw the lines with OpenGL lines, the topology, and just set the width, but I don't know if that's great. Yeah, there's I know you can draw lines with the OpenGL lines thing, but I don't know. I can't remember. There was a specific reason the first time I used them where I was like, I didn't want to use the OpenGL's built-in lines for whatever reason. And I can't remember if it's just because the stroke width is a state thing, so you can't batch together like several different stroke width lines, which may have been the primary reason I didn't do that. But yeah. And you can do it with geometry shader, so it'll be the same at time, so it will all the time look at you. Well, that's basically what I'm doing in the renderer already. So if you look at the renderer code, basically I just have the start and the end of the line, and then I get the camera's transform, and I am calculating all this stuff. But basically what I'm doing for now is I'm just saying like have it go up in world space for now. Otherwise, if it's like already like a vertical line, then have it go to the right instead. And I've done some experimentation with like using the cameras up and stuff. So like if I change the perpendicular vector to be like camera transform dot up, it looks a little bit different, but it doesn't look good. So like if I do this, you'll notice the lines look different, but you still get the same problem. So I'm like, not quite sure. Actually, those ones look pretty good. Wait a second. I think you might have just triggered something for me, Tree. Okay, so I'm going to use the camera's up transform, and then otherwise I'll use the camera's right transform if they're vertical, or like the same direction as the camera's up. Let's see if this works. That would be really cool if that just works. Okay. I might have had that backwards. First of all, I'm going to turn off gravity because that's very disorienting. So let's turn gravity off real quick. And we'll get back around to that once we can debug that stuff. Okay, so yeah, that doesn't look like it's working quite the way I think it should. Because as I go down, they just kind of turn and then disappear. Yeah, I think that's the main problem I had too. Because like, since I'm using the camera's up vector, it's like, as I turn the camera up and down, it kind of changes, which is not the effect that I want. So I have to cancel out that rotation somehow. So I'll probably just look at it a little bit more in my off time to see if I can figure something out. For now though, this works pretty good. And I'll sort of experiment with this a little bit later. So I'll just keep it this way for now, because it still achieves the same purpose, right? We can tell where lines are in 3D space, so we should be able to debug things, which is the most important thing. Yeah. So basically we can visualize like the box colliders, which first of all, don't know why the top is so much higher than me. I should probably add an offset to that when we get a chance so that our camera is actually a little bit higher. But for now, that's pretty good. I think I should probably also add rotation to this so that we can actually see what the box's rotation is. But this is another question. If you actually look at Minecraft, so let me just Google it and see if we can see that. So Minecraft hitboxes, you'll notice that they never turn with the character. So let's see if this loads up and if they have some pictures. Okay, we might just do a video real quick. I'm just gonna mute this though. So
their fortress. constant fresh supply of new spawns.
If we can see this.
Pick some slabs and just even this out right up
I'm looking
here
for like entities or
with these-
something, because that's when
Alright
you'll really be able to see
guys,
it.
this is Doc M with another Minecraft video, and I'm
No,
joined by
Minecraft
Method.
Wiki is failing me. We'll just do Google Images. Okay, there we go. Yeah, so you can see that like that llama is rotated, but his hitbox is not. And then especially this, like if you look at the player, the hitbox is just a box that's aligned with the world's axes, and it's not even the full length of the player. So it's basically just the camera's hitbox, I guess, in that case. But yeah, this is like an important question too, kind of. So it's like, in the game, do we do axis aligned bounding boxes that never rotate, which would simplify the physics a ton? And how's it going, Joe Mega? Hope you're doing all right. So do we do that, or do we add rotations? Because I do eventually want to extend this into my own game. And so rotations would be, I'm not sure how that would affect the gameplay and stuff, right? Because then if you're rotated, like if your character turns, then all of a sudden when you hit the corner of something, you actually catch on that corner. And I don't know if that is desired or not. So, yeah. And we are copying Minecraft, so let's do it like Minecraft. I like that thought. So this will simplify things quite a bit. Basically, what I have so far is I'm using the separating axis theorem to figure out which axis we're penetrating on. And so if we change this to, instead of box versus box, to be just axis aligned box versus axis aligned box, this will significantly reduce the headaches, right? Because now all of a sudden the test axes are not all of this stuff. Instead, we just test GLM vec3 100, and we also test GLM vec3 010, and we test, and this should be changed indices, vec3 001. So we just have these three axes to test. So if we change this, that does significantly reduce our problem space. And then we can change this to just be 3. And we just have the world axes, which are the things we'll test since we're just doing that. Yep. Not bumping into a corner is called the capsule collider. Yeah, but then that complicates physics even more too. And I figure, like Tree said, if Minecraft can do it with boxes and it still feels pretty good, you know, I mean, I think they've shown that it's okay to do it, and this simplifies the physics so much more. We also don't have to worry about like accurate physics resolution and that type of stuff too. So that's a real huge time saver, because Minecraft physics is just Minecraft physics, right? And most game physics isn't really realistic too. Unless you have like boxes or something inside the world, then those behave realistically, but character movement is never implemented like with the physics engine in most games I've played. There are a few that do it pretty good, but most games it's like you just have some sort of hard-coded player physics, player controller physics, and then the environment is real physics. So yeah, you're going the easy, boring route. Yes, I am, because physics is hard. I already tried the whole coding a physics engine thing, and that did not turn out good. So I think this is probably the best course of action. Okay, anyways, though, so if we just have to test the world axes, then we can literally just find the minimum penetration on which axis and check if we are colliding along any of these axes. If we are, then we return, well, if we find a separating axis, then we're not colliding. So we return the result. Otherwise, we get the minimum penetration and we get the axis of penetration, and then we return the result as a manifold. So yeah. Physics is also fun. I agree, but it's also very time consuming, and I don't have the time to spend on making a robust physics engine. So I'll leave that to the experts. But yeah, so basically we just return this collision manifold, and we should just be testing these three axes for now. And we basically just resolve it by moving the transform's position along the axis of penetration by the penetration amount. So that's basically the idea of what I'm going for, and I just need some debug drawing to see where I'm going wrong, and then we'll hopefully be able to fix that. Also got done with your basic containers, so finally working on your string. Nice. String stuff is annoying, so I'll be interested to see how that goes. Let's see if this fixes it, though, real quickly, by just returning, or first of all, I have to turn gravity back on, but just by removing all the extra axes of penetration and stuff, because that does simplify things a lot and may fix whatever problem I was having with rotations. So we'll see what happens here. Okay, so if I hit the ground, no, it's still not working right. And when I change my camera angle, it's still messing with things pretty big time. So we'll take a closer look at what I'm doing. Okay, so basically what ends up happening, and this is for my benefit as much as for your guys', is I have to sort of walk through what this code is doing because physics is not my strong suit. Okay, so basically we get the rigid body for every entity, and we get their transform, we get their box collider. Their transform is the position of the box collider. We should probably add an offset to the box collider because, like I said, we're not quite at the place I want it to be. So for now, I'll add it here, but we're not going to use it. We'll add that in after we get the basics working. So transform defines the center of this box collider, offset by whatever the offset is in there. Rigid body defines just sort of the velocity and stuff. We increment the position by the velocity, by delta t. We increment the velocity by the acceleration, and then we also add gravity to our velocity. So we just sort of add that in. I guess we could add that to the acceleration too, but I'm keeping them separate just because it keeps things simple in my mind. And then we clamp the velocity according to the terminal velocity so that we don't exceed too much. Okay. And then after we do that, we're drawing the boxes of our rigid bodies. So once we get more entities that have box colliders, we should be able to see those as well. And we'll probably add some global statements to check that and stuff. And Essie Woods, do you think I need to prioritize? Just think the entire team's work only on physics engine part. Yeah. If you ever want to finish something, you must learn to simplify, in your opinion. Yeah, that is, I agree with that wholeheartedly. It's hard to choose your battles. And in the past, I have chosen the wrong battles. So I'm trying to make it, choose the right things to work on for this, get the core of Minecraft working. Like, I implement the entity component system because that's pretty simple and it's fun to look at and to explore how that works and stuff. So I feel like that's an important part to include in this series, but for physics, I think just mimicking what Minecraft does right now is probably a good idea. Okay. Anyways, once we do that, we say resolve the static collision, and resolving, so the reason I call this static collision is basically I'm resolving any collisions with the world. And we can simplify this a lot more too, which I probably will do. But basically, we're in luck with the world because it's already partitioned, right? Minecraft is a grid. So we don't have to worry about any sort of partitioning schemes, which is super nice. Instead, all we have to worry about is, are we hitting any of the world's blocks? And Jomega, it's different for you and me. You're making game, making engine. Yes, that's true. But yeah, so Minecraft is already in a grid, so we've already got the space partitioned. We can simply look at the box's positions. So basically what I'm doing here is I'm looking at the box's front, back, left, right, top, bottom. What I could do instead of that is I could just loop through a specified area around the box colliders. And we loop through that specified area and see which grid points we're hitting, which are just cubes or whatever bounding box is there in the world. And then we can just resolve the collisions with those blocks. So that's really nice. But yeah, anyways, I'm doing that manually right now. We'll probably switch that up in a little bit after we get this working. But once we do that, we basically say, okay, so let's get the position of this block, and we create a fake box collider, which will be part of the block's sort of format in the future. For now, though, it's just 1 meter like Minecraft. And so anyways, we define like its upright orientation scale, all that stuff, which we don't really need anymore since we're not paying attention to orientation. And then we basically just set its position. This does not look right. Well, yeah. This looks right, maybe. Yeah. So basically we set the position based on whatever its world unit is minus 0.5, 0.5, 0.5, because that gives us the center of the block, which is good since the size is 1. We'll end up on like the world edges with this. So hopefully that's one thing I have to check. And then we basically just get the collision manifold, and we say if it collided and it is a solid block, then we move the rigid body that's dynamic out by the axis of penetration. Okay, so that's the plan. So now we just have to make it work. And 3D or 2D engine. Okay, yep. Cool. So now that we've got all this, I think the next thing I need to do is sort of, we'll say render draw box, and I'm going to do the block transform dot position and the block transform, or actually I guess the default block collider dot size, and we'll do styles default style. Okay, so we'll draw that too so that we can get an idea of what's going on. I'm going to comment all this stuff out so that we can constrain this to just one thing, which is the bottom block. So the block that we're hitting with our feet. If we can get this working right, then the rest of it should be pretty easy. Okay, so we'll do this. We should see a box below our feet that's drawn and sort of follows our feet, hopefully. Or the bottom of the box collider, I guess. Okay, I don't see anything. That might just be because it's solid. No, I still don't see anything, so that's not... Well, actually, now I do see stuff. Okay. I think, first of all, what I need to do is, if bottom block is solid, I'm going to, like, start single-stepping the physics here. So, real quick, what we're going to do is we're going to say, add, like, static boolean single, or I guess that, single-step physics equals false. And then inside of here, we can say... if single step physics and input is key pressed. I need to get input real quick. So we'll say include input or core slash input. Okay. So if that and input is key pressed, we'll say GLFW key space and debounce is less than 0, or not single step physics. So if we're doing this, or if we don't have single step physics on, then we'll update the physics. This way we can just sort of pause things and stuff. Okay, so we'll do that. And let's add a debounce in real quickly. So static float debounce equals 0.0f initially, and then we'll just do debounce minus equals dt. And once we hit this, we'll say debounce equals 0.2f. So we'll just sort of add in a little bit of time so that we can press the space key. I'll eventually change, like have a begin key press and stuff like that. But yeah, so we'll single step the physics. And then what I'll do is I'll just pause the physics once we hit something. So down here, I'll basically just have like a static bool pause equals false. Or actually, I should probably set this to true. Yeah. And then we'll say if not single, or if not pause, then we'll say pause equals true. I'll set that to false actually. And then we'll say single step physics equals true. Okay, so that should pause it the first time we hit this, and then we can sort of continue. And I'll add in one more thing here. We'll say if input is key pressed, GLFW key C for continue, I guess. Then we'll say single step physics equals true. Okay, cool. So now we should be able to pause and start this. So once we hit the first solid block, it should pause our physics. So we'll be following, and then we should stop. Okay, so then we stop moving. That's good. And if I hit C, we should continue, but we're not. So if I hit space, we do continue though. So that's good. So like if I hit space, you'll see we single step 0.2 seconds at a time. So I just need to change this to, okay, so that looks right. And then let me just double check this thing again. So that's a static variable, so that should be false the first time. We say not pause, pause is true, and then we set this to true. Oh, this should be false. Okay, there we go. So yeah, so this should allow us to basically pause our physics, which will be nice so that we can sort of look at this one time frame at a time. And then I'll fix the delta time so that it's like a fixed time step. Okay, so if I hit C, everything starts continuing again. Cool. Okay, so this is all good. Now we can sort of test things. I'm going to catch up on comments real quick. Okay, so kind of talking about string stuff. String stuff is annoying, so have fun with that, guys. Okay, anyway, so we've got our single step physics. We can now move this out first of all. I guess what I'll do is I'll just have all this stuff inside the single step physics. So let me get this, and we'll say if that, then I'll wrap this stuff up. And then when we resolve the static collisions, I'll wrap that stuff up as well. That way we can still like render the hitboxes and stuff, and we should be able to see those as well. Okay, so doing all that should be fine. And then I'll just remove this and we'll put it into here. Okay, yep, that's good. I'm going to copy this one more time. And then inside of here, I will just move that into here as well. Okay. Cool, so that should be good now too, and we should be able to see our debug boxes still, which will be good. Okay, so I can see my debug box, and it shouldn't disappear when we hit the ground this time. It does not disappear, so that is good. And if we hit space, we single step, and you can see we're just falling down. Okay, cool. So this is all working good. And this should be fine too. Yep. I should probably do this before we do this pause thing though, just because that's probably a little bit better place to have that. Okay. Now I have to debug this, so that's the hard part. And has Gabe used Vulkan? I have not. I want to experiment with it at some time. I just haven't found the time to do that yet. So hopefully, yeah. Okay, so if we single step this, you can see we're falling down very slowly. The thing that concerns me right now is we're not seeing any other bounding boxes, and we should see a bounding box down there for the box that we're colliding with. So something's going wrong there. So basically, I think that's probably the root of this problem. So the way I'm calculating this is I'm using box bottom, which is basically just the bottom of our collider, which is our position minus our transforms. Okay, this is, yeah, this is where it's going wrong. Okay, let's change this to GLM vec3010. And that should probably give me something that I'm expecting. So now if I do this, let's see what happens. So you can see there's, okay, yeah, so we've got two bounding boxes now. And this is the bottom bounding box is right here. And then you can sort of see my bounding box within me. So if I hit space to single step this, we're following through still. So that's not good. We should be like stopping on top of that. Okay, so that's good. We figured out the first problem, which is where is this box? So that's that problem solved, but we're still falling through it. So what's going on there? So basically I get the box position, we're drawing it there, and then I say collision equals box versus box. So what this does is we get the x-axis, z-axis, or y-axis, and then z-axis. And then we loop through all of these axes, which should just be 3. So that's one problem too. And that actually might be the problem. Okay, so let's try this again, because I think I might have just been collecting garbage there, and that's not good. Okay, so that box looks slightly out of place too, so I might want to fix that. Okay, and if I hit space, we're still falling, but it looks a little bit better, I guess. I should probably start debugging by drawing the collision vector and all that stuff too. So let's go ahead and draw that stuff too. So if I go ahead and say render, draw a line, we'll draw from the blocks transform dot position to block transform dot position plus collision dot axis of penetration times 2. And then we'll use a green line. So I'll say style green equals that. And then we'll say green dot color equals hashtag 00ff00. Okay, cool. So we should get a green line drawn where our axis of penetration is pointing. So this should be pointing up, because I'm assuming that's the axis that we're penetrating here. Okay. That was weird. So first of all, we didn't like draw anything for a long time. And now this is weird too, because it looks like it changes depending on which way my camera's facing again. Okay, so that's not good. That should not be changing depending on our camera orientation. So I got to check that out too. Okay, so I'm going to constrain this a little bit more to exactly what we're working with. So let's just remove all the extra stuff that we don't need. So I'm going to remove all that, and I'm just going to get rid of all this because we're going to be changing this anyways. Okay. So basically we have the box bottom, which is our transform's position. Is this right? Yeah. Okay. So this is our transform's position minus 1 in the z direction times our box collider size. So that's sort of our normal times 0.5. So that should bring us down half of our box collider size. And then we get the bottom block. So whatever block is located there, then we draw the block collider. And then we get that position of that block, which should be good. And then we're calling this, which uses just the X, Y, Z axes. So that's good too. And then we get the axis of penetration, which is initialized to 0 vector. Okay, this is probably where we're going wrong. So we're using the box collider, transform box collider, and the axis. Okay, no, this does look right. So we say get interval, which gets us basically just like the minimum and maximum penetration. And we just project that onto whatever axis we're looking at, which should just get us like the bottom and top right corner. So this is just the separating axis theorem. And this all looks right too. Okay, and then we basically just say return b.min minus a.max if we do have a collision, which should give us a positive or negative value. Okay, so I'm not sure how the camera could be affecting any of this stuff, which is kind of weird because we're using these axes, which I hard coded in. Okay, let me look up here again real quickly. Okay, we'll run this one more time. All right. And it takes us a while to hit the ground too now, which is kind of weird. Okay, I think the camera rotation might just be the render and not necessarily the line itself. Okay, so I don't think we have to worry about that. Oh, cool. I can still move around and stuff too, so that's probably not good. But it is kind of good because it gives me a little bit more of an idea of what's going on here. I think what I'm going to do is I'm going to make it so that we're not controlling the box. We're just going to have a box spawn into the scene because that'll probably be a little bit easier to debug and stuff. So let's go into the world and we'll just spawn in another entity, and that will be the one that we're sort of testing. Okay. So I think I load the player in up here. Yes. Okay. So let's basically just copy this. And then I'll paste it. And this will just be a random entity. And we'll add it a transform, box collider, and rigid body. We'll give it all the same positions and stuff. And then I'll just remove that. Okay, cool. So that should give us what we're looking for. And then I'm going to remove the box collider and the rigid body from our player so that he can just sort of move around freely, and go into the player controller and change this up a little bit too. So if we go press W key, then we're just going to go forward. So let me just change this to transform dot forward times speed. And then same thing here. And same thing here. So transform dot right times speed. And same thing here. Okay, so now we just have a random entity that should be spawning in. We can sort of take a look at that, which will be nice. And I just have to fix this. So let me just call this transform2. And we'll do that. Okay, cool. So let's take a look at this now. Nope. Okay. Entity 1 does not have component. Okay, so I'm trying to get a component that doesn't exist. Let's see. Oh, this should be right here. Okay, there we go. I was just getting that off the wrong entity. Okay, so now we should be able to sort of observe things from a different perspective, which will be nice. There we go. Cool. So now you can kind of see that box falling. I'll probably spawn myself closer to the ground so that we can see this a little bit better. Awesome. Okay, cool. So now we have this box, which is an entity. And then we have the box it should be colliding with. And you can see what it says the axis of penetration is, which is definitely not right. What I want it to be is the top block. But looks like that's not what we're getting. So I guess this is what we have to fix. I'm also going to do this too, just so we can debug this a little bit better. Going back into the physics. So we're drawing the axis of penetration from the block's position. What would be really nice is if we could get, well, actually here, we'll just multiply this by collision dot penetration amount. Okay, so that should give us an idea of how much it says it's penetrating. It won't give us the point of collision, but that shouldn't matter because all of our stuff is like, it has no orientation and stuff, so we should be able to just offset things by the origin, and that'll do the same thing. Okay, cool. So that does look right. So it's saying we're colliding by that amount on that axis, which, if we look at it, I think that looks right. Yeah. I would show like with my hands and like show you guys on the screen, but I can't really do that. But yeah, so that looks right because that's the amount that we're penetrating along that axis. And that is the smallest amount. But basically what I want to happen is it should be going along the vertical axis. Let me hit space and we'll single step this. So it should push it to the left if this is working properly. But nothing's happening. If I hit C. Okay, there we go. Yeah, so it did push it to the left. Okay, cool. So that's interesting. When I hit space, it should single step things, I think. Unless I change that. So we have if... Did I change that somewhere? I might have removed that on accident. Okay. Wait, no, yeah. So if single step physics and input is key pressed space. Okay, so I just need to sort of change this. We'll add one more Boolean real quick. Static bool step physics equals false. And then when we hit the space key, we'll say step physics equals true. And then I can just use this Boolean instead. And then we need to set that to false right here. Okay. So we'll do that. And we should be good now. Cool. I guess this really should be abstracted. Okay, so let me do this real quickly. So we'll say if space key is pressed and stuff, then step physics equals true. Okay, and then otherwise we don't do anything. Okay, and then we'll say debounce equals 0.2f. And then we'll just do if step physics or not single step physics, we do this. And I'll change that. And then I'll change it down here too. Okay, cool. So now we should be good. And I'm just checking the chat real quick. So I think the problem with the player going through the ground is that you're falling too fast and collision happens between frames, so physics engine doesn't record it. Yes, I do agree with that too. A simple solution would be add a simple line, not a raycast, just a line at the bottom of the player to check for the collision too. Yeah, so what I'm going to do, we'll experiment with this a little bit more, is sort of check an area around the player for blocks, and we'll check this out. Okay, but not entirely sure about that. Box 2D max velocity is 120 meters per second found. Okay. He's using Box 2D since it's 3D game. Yeah. And Jomega, yeah, issue looks like the physics is discrete and not continuous. Yep. Yeah, we'll check all this stuff out. I don't think it's the physics right now being discrete, because what it looks like is the axis of penetration is pointing to the left. So it looks like we're resolving collisions to the left and right instead of up and down, which is what I'm expecting. So I don't think we're actually like ghosting through the object. It just happens all so fast that we don't really see that whole thing happening. So that's why I'm adding the step physics into here so that I can sort of step through it frame by frame. Because if we look at this again, yeah, so you can see them fall. And then if you notice, they do stop at the first block, which is good. So we're not ghosting through this block because we are hitting it. It looks like we've actually only gone a pretty small amount, but it's trying to resolve it along this axis. So if I hit space, you'll see that it pushed it to the right, and then it's pushing it to the right again. And so what's happening is it's going over here. And then once we get to here, it gets to a vertical collision. At least I believe. And then it starts pushing it down. Yeah, so now it's pushing it down. And so I think that's our problem. And if we just let it continue, you'll see it falls down now. Or actually, I guess it's in between the blocks is what's happening there. Okay, but yeah, so basically we're just getting the wrong axis penetration. And yes, I'll probably have to take velocity into account too. But the problem is I'm not getting the right axis of penetration. So I'm wondering what the best way to do that would be. So usually, yeah, I think usually what you would do is you would get like proper physics collision resolution and stuff, which does take the velocity into account. And then we basically go backwards along the velocity. And I think that's probably the best way to go here too. But yeah, we'll have to see. Physics definitely is not my strong suit, so this stuff is always fun to work with. For now, if I just go ahead and say like use the vertical one. So if I just took these two axes out, we'll say 0, 0. This should make the right thing happen, not for the right reasons, but it should allow us to see if that at least works. So yeah, if we do that real quick. Nope. Okay, I think it just fell through the world. Probably because I'm doing like zeros here. Okay, so instead what we'll do is we'll just make this one, and then I'll just do that one. Okay, let's see what happens now. This might be another problem too that I'm thinking of, but we'll have to take a look in a minute. Nope. Okay, cool. So then we do stop there, which that's not the right place at all. So I'm not, okay, so that looks like another problem that I have then, which is it's not detecting the right blocks. So it thinks that block is solid for some reason. And then it thinks all those blocks are not solid. I don't know, this is weird. Yeah, this definitely doesn't look like it should be happening, so not quite sure what's going on there. I mean, it's closer to working physics though, right? Yeah. The physics series is well done, Gabe. Thanks, Essie Woods. I was basically using this book to start the physics. So he does it properly. He actually does do collision resolution, everything the right way. So let's take a look in here real quickly, just so I can review this stuff again. So if we scroll down to 3D collisions, which is somewhere down here. So he does manifolds and impulses to resolve the collisions, and that's sort of, I mean, that's the proper approach, but I feel like it'd be easier if we didn't have to do that. 2D is so much easier to deal with. Oh, and it's something, but not sure that it's physics. Yeah. Okay, so if we take a look at this, and I definitely am a physics noob. Most of the physics tutorial series is me basically just reverse engineering other people's stuff. When it comes to creating my own things, I'm still not that good. When I'm doing 2D physics, though, it's a lot easier to conceptualize that stuff than it is once you get into 3D, and just because of the third axis. But this probably isn't going to be helping me. Wait, whoops, didn't mean to do that. Okay, so let me go down to chapter 3, 4. Okay, shape intersections. So this is probably what we want. So we'll do axis aligned box to axis aligned box. Yeah, and so this is sort of what we're going for. So we're testing to see if two axis aligned boxes are overlapping. I think this might still be 2D though. Hopefully not. Okay, yeah, XYZ, cool. And when you're investing in a 49-inch computer screen, your brother wants one. I don't know. It depends on who you are if you want to get a 49-inch computer screen or not. I personally like having multiple monitors, but some people like having a really big computer screen. So, you know, just depends on the person. Like 30 meters wide, I hope not. That's a big monitor. I think. Yeah? No? I don't know. I can't do meters to inches. 49 inches in meters. Okay, yeah, so 30 meters is huge. Okay. Anyways, let's see. So given shapes A and B, we have overlap only if the minimum of A is less than the maximum of B. Yes, so this is basically just detecting if two objects are colliding. Oh, so the way he does this is he just gets the minimum point of A and the maximum point of B, and then just checks to see whether one is greater than or less than or equal to the other. That's probably a good idea since we're keeping them aligned to the axes and stuff too. But here, I'm going to switch to the drawing screen so that I can sort of think a little bit easier real quickly. So basically, yeah, so basically what we have going on here is we have the separating axis theorem telling us which axis should be colliding, or at least that's what I want to happen. What I want to happen is ideally this would give me like this axis, and we would get that distance too, and then we could push this box out by that much, and we should be good. But I think what's happening is, like in our case, we have a box that's falling. So we'll say that's the box, and then we have the ground, which is like right here. And basically what it's giving us is, first of all, it's looking for the axis of penetration. And we have two axes that we're penetrating along here, right? So we have a collision here, and then we also have a collision here. This collision is 1 unit, this is 2 units. And since this one is smaller, it's trying to push it out this way. But the problem is we also have a block here. So I guess what I could do is I could combine several blocks, right? So if there's more blocks over here, then we could combine those blocks too. And then it would make this axis look way bigger. So this would be like 4, and then it should push us out this way. This might be the best way to kind of go about this, because then it should push it along the right axis. Basically what we're trying to do is we're just trying to make sure that our character doesn't go into a block, right? And so I'm not sure what Minecraft does to simulate this, because they definitely don't use like normal physics stuff. But yeah. The simplest thing we could do is we could just set the character's position to like whatever this height is. I don't know. I still have to think about the way I really want to do this. For now, I think what's easier is probably if I just go back to the debug lines and see if we can get those working right, because that'll be a little bit easier to work on for now. So we'll take a look at that. Or actually, I could probably work on the fog and stuff too, because that's something that I also need to get done. So yeah, the fog should be pretty easy to do. I'm probably going to do that real quick instead. So basically the way I have the fog working right now is if we take a look at our default shader, I basically just add in a fog position somewhere down here. Yeah, so we get the ambient light, we get the light direction, and then we get the distance to the player. So we get the fragments position minus the player's position, which is the distance to the player. So this is for the chunk rendering. And then we basically divide the distance to the player over the chunk radius times 16. So that should give us a normalized distance. And then we calculate the fog color depending on that normalized distance, which is why it fades out as it goes further away. And Jomega, you'd say, fog, are you trying to hide rendering limitations? Yep. In Minecraft, at least. I'm pretty sure, like, I don't know. I guess in modern games, you could do LOD stuff to make it disappear as it gets farther away, but there's always rendering limitations and stuff, and you don't want the whole world on the screen at any given point anyways. But yeah. Okay. So if we just want this to grow as we get farther away and be small as we get closer, we can basically turn this into like an exponential function or something like that, where basically we just sort of move it based on how far away we want it to start. I think. Where am I even using this too? So this is D. Okay, so we do fog color times D. So basically this distance sort of determines how intense the fog is. Oh yeah, because we're just mixing these two colors. So we mix the result and then whatever percentage of fog we want to take over the screen. And in my occlusion culling is already a huge help when it comes to rendering. It's useless for ray tracing though. Yeah, that's true too. And you can probably do more occlusion culling and stuff too. Like we could occlude chunks that are hidden from the player to just get rid of that render time, which I might look into because I still am not really happy with the frames that we're getting and stuff. But yeah. Anyways, though, so basically we'll want this distance to increase as it gets farther away from the player. So right now this is going from 0 to 1, and we basically want it to like, we'll just clamp out like 0 to 0.5. So we'll just say this plus 0.5. I guess that should work. So we'll do this plus 0.5, and then that should just push the fog further back. So we'll see how this works. This is definitely not the right way to do this too, but it's been annoying me for a while. Nope, I think I did that wrong. Yeah, I definitely did that wrong, but let me do minus 0.5 real quick. Just to see what this does, because I think my fog is not working the way I think it's working. Yeah, because I think I'm basically taking the Z index into consideration too. Okay, there we go. That looks a little bit better. But I'm also taking the height into consideration, which, I don't know. I guess we should, because Minecraft does that too. But yeah, this is acceptable for now. And then I just have to fix this physics eventually. And then we'll just clamp that to 0. So basically, if the fog is 1, then we get So if the fog is 1, then we get 100% of the result. And then if the fog is 0, okay, if the fog is 1, we get 0% of the result, and if we get 0, we get 0% of the fog. Okay, that makes sense. So then we can just clamp this to 0 and 1, just to make sure that that is in an okay range. Okay, cool. So I think that should be fine. Yep. Okay, cool. So that definitely looks better now. And we've got kind of a light fog that goes around the screen. Cool. At least one thing is easy, right? Fog is never too hard. You can do ray tracing the Wolfenstein Youngblood way. Just throw the entire level into the volume. And it's insane how much YouTube content that has created from the Minecraft game. Yeah, that's true too. So I'm trying to think of what else I should probably be working on right now too. And you think you got all the function E for your string, almost 1K lines, but most of it are Doxygen comments. Wow. That's pretty good. So once we get physics working, I'm trying to think of what the next best step is too and stuff. I guess like proper terrain generation is probably a good idea to be something that I should be working on. And then like generating structures and stuff. One thing I still need to fix, which I haven't gotten around to, is actually culling out the interior faces inside chunks. And then we also have problems like this where it's like random chunks are missing. So I'm still not quite sure why that is, but we have to cull out this stuff too, because that's a waste right now. And I think I have some to-dos in the code. So let me look through for that real quickly, because it's probably a good idea to just check those out. So we'll say to-do. No, search for to-do inside of our project. Okay, I'm just going to take a look at these real quick. Yeah, this is not what I want to look at. Okay, so the world. Figure out the best way to keep transform forward, right, up vectors correct. So this is an interesting problem too. There are multiple different systems that can change a transform, right? Like physics can change your transform. Controllers, character controllers can change your transform. And other things can change your transform. How do you keep all that stuff in sync so that like if you have a transform, say like in my transform .h, or actually I think it's in components.h. Yeah, so basically I have these vectors, the forward, up, and right vector for convenience. I know I could probably have these embedded inside of like a view matrix or something like that, or a model matrix. But how do you keep these in sync as different things change the transform's position, scale, orientation? I don't know. That's something I'll have to look into a little bit more. For now, I'm just sort of doing it right here. Let's see what else we have though. Okay. Oh, I guess I don't have a lot of to-dos in here. Which I guess is a good thing, right? Let me see. I just want to kind of look through the code, because there's a lot of different problems that I'm encountering that I think I should probably be working on to fix and stuff. But yeah, for now, one thing I can do is we'll delete this world stuff. Okay. Wherever our chunk files are, because I want to start generating them automatically. Let's see. No, I don't know where our chunk files are. I guess I might not be serializing them. That's probably something that's important to look at though. Let me see if I'm serializing our chunks real quick too. Sorry this stream is so scattered, by the way, too, guys. I didn't have too much of a plan today. Except for, like, I need to get the physics working. So that's kind of why it's all over the place right now. But I don't think I am serializing our chunks. So if I go into the chunk manager, And I also don't have my mouse capture on. Okay. So do we serialize these when we get rid of them? Okay, so we basically say we're deleting it and we're creating it. And it doesn't look like we save it. Okay, that would probably, or actually no, when we free it on the CPU, yeah, when we free it on the CPU, I think that should save it. No, it does not. Okay, so that's something that we should probably add back in. Before we do that, we should say chunk.serialize. And then we'll give it a world save path of world slash, we'll say chunk coordinates x and y. So that should be like the XZ coordinates. Or actually, I think we can just do this, right? So if I just do serialize, what does this do? Yeah, so then this just formats it for me. Okay, cool. So we'll do that, and then we'll deserialize if we can. Oh, wait, no, yeah, I am doing that right here, right? No? No, I'm not. Okay. And then otherwise, when we're loading a chunk, we'll generate if chunk exists, and then we'll say world, and I'll get rid of that. And then we'll give it the chunk coordinates x and chunk coordinates z. So if it exists, we'll load it. Otherwise, we'll generate it. Okay, so that's probably something that we should have had in there too. And then we'll just say chunk dot deserialize. And then we'll just give it those coordinates. And this should be y. And then we'll say generate render data, which should happen regardless of how we generate the data. Okay, cool. So that should just get saving and loading done again. I might have to create that path too. Are you seriously getting the transform for your ECS whenever you need to change a single value? Wouldn't it be better to just get a reference to the transform and use that? Yes, that's what I typically do, is I just get a reference to the transform. So I'll revisit that in a minute, but that should have serialized everything. But it did not, so I'll have to check that again. But yeah, whenever I need the transform, I check it. So if I just go into the physics, yeah, so whenever I view the transform, I just get a reference to the transform here, and then I just use that from then on out. So yeah. Okay, so doesn't look like we're serializing these yet. I think we need to serialize when we exit too. So when I clean up, which is right here, so this joins all the threads. Yeah, I'll have to take a look at that in a minute too. Yep. There was a spot where yours didn't. Yeah, I mean, it depends. Sometimes I'll get like a reference and then change it. And then sometimes I'll just do get. I'm not sure where you saw it where I wasn't, but, oh, it was probably inside of the world.cpp. Right here. Yeah, it's because this is kind of hacked together. So the reason I did it this way is because it should not stay this way, because this is like very temporary code. Yeah, so don't worry, I don't do this every time. And it's also, I think it's because I'm just like using, no, yeah, I am doing this twice, but it's very temporary code. So the reason I left it like that is because I kind of want it to be ugly so that I remember to remove it and stuff. But yeah. Okay, I'm really not sure what I should be working on right now, because I know I should be working on the physics, but this stuff is usually better to work on when I can like focus completely. So it's probably gonna be better if I work on this on my off time. But I'm glad you guys were able to come to the stream. Hopefully next week's stream is gonna be a lot more structured than this, because I was sort of all over the place today. I'm definitely going to try and come to next week's stream with more of a plan so that I know exactly what I'm going to try and accomplish, and then we'll get that done during the stream. But I'm probably going to work on this in my off time, and I'll see you guys next week. All right? It was good to see you guys. I will see you next week, and hopefully I'll actually have a plan then. All right? So thanks.